Okay, guys, now I want to go over the mass analysis tutorial. Don't neglect this feature of this program. Engineers not only design, but they analyze their data to make educated decisions using the science that is involved. And so this is a great piece of technology. It allows us to look at the forces that are acting upon our dragster. So here's that dragster that we developed in the modeling tutorial number 1, and we're going to put it through the mass analysis tool to see what we've got here. Okay, mass analysis. The tutorial itself is found in the help tab, and when you get to the analysis section of the engineering build, walk through this first so you understand what you were doing there. What we'll do is we'll click on the little wrench here and open the mass analysis of the current design. This is the design that we did in tutorial number 1, the modeling tutorial number 1, and these are the statistics. We're looking at the overall mass. Remember, mass is the amount of matter per given volume. The body itself, that's the red block here, has a mass of 37.87 grams. The front axle assembly with the axle and the wheel and the bearing has this mass. The rear axle, this mass. The total designed mass of the vehicle itself is 66.81 grams. This is significantly heavier than our minimum of 30 grams. So we have a lot we can take down in our modeling. Mass analysis is a very critical tool in design, and you're going to find the lighter your car is, the faster it's going to go. But it is important that we have a good stability ratio as well in your design. So this tool is going to help us do that. The tutorial explains our different elements of the mass analysis tool and how they're calculated. Let's look at the center of mass here. If we click on this little eyeball right here, we open up a table, and that table corresponds with the car itself. And notice these little balls. You can rotate your car around. Here is the center of mass for the entire vehicle assembly. Okay? Where this is positioned relative to the front and back axle is very critical. We don't want a center of mass behind the back axle, for example, where your car is going to tip up and do wheelies. It's not going to be very stable. So make sure you pay attention to how your mass distribution is. The body mass, okay, without axles and wheels on there, is slightly forward of that center of mass, and that makes sense. Remember, we got a cartridge you're putting back in here, and that's going to pull back that center of mass. A lot of things that are affecting it. Here we're looking at all of those center of masses and how they work together. Consider this in your design. So the importance of the center of mass with the stability and performance of the car is critical. And you may know this with the example of low racing sports cars, sedans, and comparison of trucks and SUVs. Those vehicles with higher center of masses have a greater likelihood of tipping over in a high-speed turn. This ratio, stability ratio, looking at the distance of the center of mass from the ground and the distance of the center of mass from the rear of the vehicle determines the stability of our vehicle. And when we look at our stability ratio, the lower our center of mass is, the wider the profile of the vehicle and the longer the wheelbase is, they all affect the stability ratio and the performance of the car itself. You can keep those in mind when you're designing your vehicle. Walk through this little tutorial here on the stability ratio. You're going to make some changes to your car. Go through these steps here, and we'll see how it affects the performance of the car itself. What I'm going to do is click on our we want a left view profile of our car. So we're looking at our different forces that are acting on our car here. We see this breakdown. And in this table here, we're going to compare our data to what they have set up as a default data, and we're going to modify and put in what we see. So looking at the mass of our front axle, come over here, our front axle here is 12.81 grams, and their default value is 22. So put 12.81 in there. For the total vehicle mass, look at our total vehicle mass is 91.81, where their default value was 107. So put ours in 91.81. The center of mass relative to the rear, come over here, ours is 104.73. And from the ground, right here, ours is 30.21. Our stability ratio is 2.17. Okay, and now what we're going to do is open the work area for the front wheels, and we're going to make a change. And we're going to see how it changes that data. We're going to change the type of wheel to an LX wheel, and we're going to apply that in place there. And we're going to see what happens and how it affects the data above. So come over here to our engineering area for front wheels. Click on that, and we're going to make a change of our wheel type. Change that wheel type. I forgot the docking station is put up here. We need an LX wheel. We're going to hit apply. So we're going to change this to an LX wheel right there. Notice all of our data updated, and it changed our mass analysis. We're going to hit apply, and then we can say done here. Okay. So making those wheel changes, we did have an effect on the change of center of mass. And here in the tutorial, they give you several questions to think about. What effect did the design change have on the mass? And is it what you expected it? Well, if you look, your total vehicle mass has gone down. You've made your car lighter. Why'd you make it lighter? The wheel is lighter. And because this front wheel is lighter, this particular one has holes where we had a solid wheel before. We've also changed the relative center of mass because the overall distribution of mass from the front of the car. What effect did the design change have on the center of mass, and is it what we expected it would happen? Yeah, sure. You make this lighter, we're going to change, and our center of mass is actually going to move slightly back. It also moved down just a little bit from where we were before. And how did that affect the stability of your vehicle, and is it what we would have expected? So when you look at the stability ratio, there wasn't a lot of change because we did have a fairly thin wheel on there before, but we did see that there was a change from the position of the vehicle. Take this, you can rotate this around, and you can see how those forces are affected and balanced in there. Play around with the different wheels, play around with the different axle types. Really use this data analysis tool, a very powerful data analysis tool, to make the best design you can possibly make, so you can have the fastest car in the class.